All right, so we got audio live. So welcome everybody to the first TWed of the fall 2017 season, and welcome especially to, first of all, to Tetherless World people. Welcome to the Amos Eden 217, which is called the Data Insight.
You're off, right?
Yeah, you're awesome. Okay, good.
To the Data Insight Lab. This was built a year ago with special funding to focus on group-oriented projects in run out of the Institute for Data Exploration Applications, IDEA. Just a couple logistical things. As always, TWed talks are being streamed live and recorded, so please keep that in mind. When you're asking questions or making comments, your voice is being recorded for perpetuity on the interweb. The schedule for TWeds for RPI, our users group, our Pirates users groups, and a new thing this fall, IDEA talks, are all can be found at tw.rpi.edu/web/TWed. The same guy administers all of them, so he maintains the schedule all in one place. In this location next week, we have a TWed talk by Alex New, an IDEA grad student. He's going to talk about cadres. It's cool stuff, and I will spam you with the details on that. And we have future talks this term by IDEA talks by IDEA grad students and special guests and all sorts of things. We have future TWed talks by TWed grad students and staff. We have, and intermingling with that, RPI, our users group meeting, so it's going to be fantastic. Only the TWed talks are currently planned to be streamed, but we may negotiate on that. Thank you, Jim McCusker, for kicking off the term, talking about this labor of love, Satoru, and we'll all learn to love it. Jim is the Director of Data Operations for the Tetherless World Constellation. And without further ado, take it away, Jim. Thank you.
Hi, how's it going? So I may decide to sit. I don't know.
Whatever makes you comfortable.
Yeah, I haven't decided. Okay, so I've been doing research on knowledge graphs, and one thing that I realized the more I looked into it, the more I realized that there really is no good reusable framework for creating knowledge graphs. As a result of this, basically we have many different projects that have been building knowledge graphs for their purposes, sometimes emphasizing some aspects of it, sometimes emphasizing others. For instance, there are many knowledge graphs that's just a Sparkle database or even a Neo4j database, and that's it. There are other systems like Google's knowledge graph that are very large scale, very sophisticated, contain many different types of curation tools and extraction tools that are kind of built in. But the main feature with all these is that they're all purpose-built. They're all one-off systems, or the tools that they're building off of are very low level, and kind of everything that they're doing above it is built just for that one project. Satoru is, to my knowledge, the first reusable knowledge graph framework. It is open source on GitHub and is a Python-based application that uses a BlazeGraph RDF database, and that actually can be interchanged with other RDF databases because they're changeable. Yeah, so you're going to learn a bit more about what it does and hopefully why I did it in the first place. So this is kind of one of my motivations for creating knowledge graphs. My specialty is in biomedical informatics, and specifically around trying to understand how graphs of biological entities like proteins, drugs, and diseases interrelate so that we can make predictions about what might affect what. And this is actually a very straightforward graph that we were able to create that actually predicted the effects of these drugs around the outside on melanoma based on the fact that they interact with these proteins. This was curated from many different databases. It was yet another manual purpose-built knowledge graph that we created just for this project. This is hopefully my last purpose-built knowledge graph. But basically, we added probabilities to the interactions, and we used something that actually has rolled over to Satoru for it, something called nanopublications, which allows to express the provenance both of a fragment of knowledge and how that fragment of knowledge is published. And actually, we had some very good results. These genes, only 3 of them haven't been studied, or these drugs, only 3 of them hadn't been studied before. So these were all valid hypotheses based on the fact that someone had them in the past.
Oh, just a question. Like you mentioned, the edges have probabilities.
Yes, the edges have probabilities.
Okay. So, and how did you actually calculate the probabilities? Like, did you go through
based on the evidence of based on the evidence that was used? So, a certain kind of experiment was performed in order to top 1 CDKN2A interacts.
Right.
And so there was an experiment that was done with the 2 of them and said, sometimes what they do is they'll have basically if the 2 bind together, they'll precipitate out.
Right.
And so that's one kind of experiment, and there are many, many other ones. We had 2 expert systems biologists evaluate each experimental method for a level of confidence. We kind of squinted and translated those into probabilities, and added that as basically a bit of manual owl inferencing using Sparkle to the knowledge graph.
Okay, so you basically got these probabilities from studies conducted on the drug interaction.
Exactly. Yeah.
Okay.
So yeah. So each of these interactions came from was curated by someone from a paper and published to a knowledge database. Most of these protein interactions came from something called IRF index, which aggregates a bunch of them together. But yeah, so basically the idea is that there's an object that has that is the interaction, and then there's provenance around it that we can take advantage of to add more sophisticated details about that and do kind of a consistent graph analysis.
Another question: why do some nodes have 2 edges? Like, what does that indicate? Like 2 probabilities?
Oh, like here?
Yeah, or 2 or 3. Yeah.
Those are usually multiple. So these are multiple kinds of interactions that occur, and they're the same color because we collapse some of the colors together. So these are all kind of activating interactions, but they're 3 different kinds of activating interactions.
Okay, so the edges have both the number, the probability, and something else to identify.
Well, it's not just so the edges have the probability, but also the type.
Okay, got it. Cool.
And we merge when you have multiple experiments saying that these 2 things interact in this way, then you end up with additional confidence. So the probabilities are merged together using something called z-score or composite z-scores, which is not important necessarily for this talk, but was kind of a cool feature of this because it helps us compound evidence together, and will hopefully be useful for future knowledge graphs.
So would you want to think of this as like a Bayesian network in terms of?
You could use it as a base net, yeah.
Okay.
The thing is that this network actually, so this is a tiny, for 1.3 million interactions added to the knowledge graph. This basically took out the strongest ones. So could use it as a base net. I wouldn't recommend it because it would be a very complex base net that would probably take a very long time to compute. But yeah, go for it. Okay. So anyway, so that project, along with a couple other projects around ontology engineering and kind of aggregation of human curated knowledge into a computable system, kind of resulted in a desire for this knowledge graph framework. So Satoru is Japanese for understanding. It is also a male first name, or male given name. So I'm sure I'll get a call from Satoru Yamamoto or something saying, let's go. But anyway, this is a word. Actually, this is the kanji glyph for it, and I kind of made it into a logo a little bit. Anyway,
If it was built with red PVC pipe.
exactly, yes. I had a real architect help me with the design. So anyway, actually, does this have a laser pointer on it?
Yeah, it does actually. Be careful.
Yeah, I don't know.
Press the little button in the middle for laser.
Oh, no.
Here. It turns itself off.
Oh, I unplugged it because it was not. Oh, I see. Of course. Oh, there we go. Is this gonna work on here?
Now, it doesn't really. No,
Yeah.
that's why I say be careful. And
Be
when
careful because it's not going to do.
well, reflection goes around the room.
Here we go. Okay, that's better. A real point. And then the people in the internet can see what I'm pointing at.
You're a genius.
Okay, so anyway, what we have is essentially knowledge graphs that can take in knowledge from many different sources, literature, databases, public data sets, and either perform semantic extract, transform, and load processes on them, or perform NLP analysis, depending on what you're working with. And obviously, there's structured data that has text embedded in it. There's text, like if you're sucking down data from the internet, you actually may be, or from the web, you may actually be able to do a structured data extraction from that, depending on where you're getting that from. So those kind of overlap and interweave based on what you're trying to do. And then basically the core knowledge graph is then mined by a set of what I call what are kind of generically referred to as inference agents. That's deliberately vague because an inference agent can be literally anything where you have basically a activation query that basically says, hey, here's an update. Is this interesting to you? That query will say whether or not it's interesting, and then that agent will then be able to process that hit and say, here's the new bit of knowledge that I'm extracting from this. And it can consult the whole knowledge graph. It doesn't need to look at just the fragment that's sent, or it could just look at that fragment. There's a user interface. So there's basically users can interact with the data through visualization, do analysis, and maybe contribute new knowledge, new models, methods, etc. And then there's an opportunity for creating cognitive agents that sit on top of that, that are able to interact with the inference agents, with the knowledge graph as a whole, to say, basically produce new hypotheses, like we did with the drug repurposing project, to say, hey, here's some new hypotheses coming, maybe automatically test them based on the knowledge and the data that we already have. Or can we, here's a hypothesis that I've discovered based on data analysis. Does the knowledge that's in the knowledge graph back that up? And so they're kind of two, we can justify analyses, or we can basically try to prove, or not prove, but try to perform experiments to validate or invalidate a hypothesis.
So the deductive reasoners, are those like owl reasoners?
Yeah, it could be, yeah.
Okay.
You can, I mean, literally this is anything. So you can plug in an owl reasoner that says, well, just show me everything as it comes in,
Okay.
and I'll add new new reasoning to it. Those are not implemented yet because it's not. I'm going to say something controversial. It's not always it's not needed for everything. And so basically this is essentially a forward chaining reasoner or forward chaining inference system. It will basically try to compute all the knowledge that it can.
Right.
And depending on the rules you put in, that might just run forever.
Right. So whoever's writing the knowledge graph has to come up with these rules also, right?
Yes. So there's some agents that come with it, but yes, when you're developing the knowledge graph, part of the process is what are my rules for creating new knowledge? Yeah. In Satoru, everything is captured in nano publications. So when I say that Satoru is a nanoscale knowledge graph framework, this is what I'm referring to. Basically, is the smallest unit of publishable information. Basically, an assertion where you're saying something. The provenance, the evidence and history of that assertion, and then the publication information, which is how did that get here? How did it get into this nano publication? So, for instance, if maybe I'm quoting a paper about a result, and I say these two things interact, I would say, in here I would say, these two things are interacting, here's how they interact. In the provenance, I would say, here's the evidence for that interaction, here's the experiment that was run, and here's the paper that it was published in, maybe. And then the publication info would be, oh, and this guy, Jim McCusker, wrote it based on and quoted it from this paper. So that's kind of the levels of what you would put in each of them.
Now, would that be like a triple, the minimal unit of thought? How would you
This could be a single triple, yeah.
Okay.
It could be.
Or it could be a graph.
It could be a very large graph. It could be a triple. In some cases, actually, depending on how you're using Satoru, you can create things that are not even triples. You can actually just have a text assertion, where you just type out what you want to type out, and it's basically a comment about a particular entity. So, and I'll show how that works too. Is there anything else? No. So, kind of diving into this publication information, specifically in Satoru, nano publications are versioned. So they're versioned and they're immutable. So once you create one, you cannot actually edit it per se, but what you can do is make a new one that's a revision of the old one. The old one gets retired to basically a file archive, and both of these point to a what in functional requirements for bibliographic resources. It's a information resource hierarchy ontology. Basically, these are two expressions of a common work of the same thing. So if you were to say reply to a user interface, you can reply to nano publications by making more nano publications. You're actually replying at the work level. You're not replying to the expression, which is kind of each version of it. Because if someone edits something, you don't want your replies to just disappear. So we need to have something at a higher level of abstraction.
So what about discoverability? Like, if I'm searching for a nano publication, I'm assuming they have different URIs, right?
Mm-hmm.
So am I getting the latest one?
You're getting the latest one, yeah.
Okay.
So you're getting the latest one, but also with Provenance saying that this is a revision of this one. And the file archive is actually accessible through the nano. So there's a linked data API for the nano publications themselves. So basically, the URI for this nano publication, even if it's not in the triple store, you can still access it, and it'll go into the file archive, pull it out, and send it back to you. So you can trace back the history. It's just not directly queryable. If you delete something, or delete it or retire it without referring to it again, it's not, you'll unless you know about it, it will fall off the edge of the earth. So I'm only showing you this because this is kind of new and useful. Setup of Satoru is simpler than this looks. Basically, you can either, if you already have a server and you want to install it directly on there, you just run this command. Actually, I think you're going to need to do it with sudo. Now that I think about it, but basically, this is an install script that what it does is it installs Puppet, and then it runs a Puppet script that installs everything else. And then basically you can go to either. Oh wait, that's not right. Sorry.
But we'll use whatever you put onto the GitHub.
Yeah, exactly. Well, so this is actually if you're running in development mode, you have the 5,000. But also this is obviously going to be the URL or wherever you set it up. You can also create a virtual machine using a tool called Vagrant. You'll need to install VirtualBox and Vagrant on whatever you're working on. Basically, you download 2 files from GitHub and run Vagrant up, and that will basically pull down. It'll create a virtual machine, populate it with the source code repository, set up all the services that Satoru needs, and get them running, and then you can visit here. The first thing that you do when you go to when you use Satoru is you should register a new user. And let me see if I can switch back here. Where did I put this? Right. So right. So that's basically where you start off. You fill out. So this is like a user ID as your as the that's used for in your user URI, and then you fill out the rest of it.
I thought the identifier was like your prefix, like Mr. Doctor.
Oh,
Yeah.
yeah, no.
I had it correct the first time.
I will change that. Or if I'm accepting pull requests. So if anyone wants to improve,
You can hit nudge them.
yeah, if you want to improve the user interface, I will gladly let you do that.
Well volunteered.
Yes. Okay, so right. So the Satoru architecture is 3 tiers because everything has to fit in 3 tiers, even though there's 4 tiers. So anyway, it'll all end in tiers.
Everything is 3.
Everything is 3, even when it's 4. Okay, so anyway, basically so kind of the core of Satoru is a Blaze Graph RDF database. There's two namespaces, one for user accounts, one's for knowledge. You can actually completely blow away the knowledge one and not lose your user accounts. This is partly for debugging and also for security, because I also supply a read-only Sparkle endpoint for the in Satoru, which BlazeGraph doesn't do by itself. There's a file archive that I mentioned before that you can access Nano publications directly, ask for them by name, and you'll get them back. That includes retired ones. And then I use a framework called Celery, which is a worker queue system where you basically push tasks to a message queue, and then one or more worker threads will grab it, perform the task, and push the result back. And that's actually what the inference agent system is built off of. And so I've kind of abstracted each of those cases I've kind of abstracted away the details of how to use that stuff. You just write an inference agent and everything else will happen for you. Kind of on top of that, we use the Flask web development framework. It's one of the more non-SQL friendly web frameworks, much more so than Django and much less annoying than, say, TurboGears. Basically, there's a view management system, knowledge REST API that lets you publish, update, delete, etc. Knowledge, a set of knowledge expansion agents and the engine that runs on top of. Basically, different tools for doing linked data mapping. This was supposed to be some other one, like you can import directly from DBpedia or from any other ones, depending on how you configure the linked data mapping.
Crossref?
What?
Why did they deal on one of the?
Yeah,
specifically-
actually, Crossref doesn't do, isn't publishing linked data the right way at the moment.
No.
Yeah, they're not, like I tried looking up my Crossref ID and it just didn't work.
Yeah.
Anyway.
And Pence, are you listening?
On top of
Yeah.
that is a number of kind of browser level things like basically there's a set of custom views that lets you see certain kinds of entities in the graph in different ways. There's a very basic one for ontology browsing. It includes a page renderer for each class in the ontology, a page renderer for the ontology as a whole, which includes a very rudimentary faceted browser. There's a couple custom things for looking at basically the DOI articles, and then there's a set of there's a few other things in there that are kind of like core pieces. So some of the pieces of Satoru is built on top of Satoru. So there's some core views that are kind of integral to Satoru, but you would extend when you kind of build out other stuff. So let's actually build some knowledge. So this is kind of how I see the pieces of knowledge graph engineering. So basically, kind of central to this is actually interaction, where you have you're doing something with it, and it could be creating a user interface that a human would be interacting with through HTML or through whatever else. It could be a data interface where you have other applications, or you have R scripts or Python scripts that are. These are all different, can be custom views that you create, where you're basically building an API inside of these interaction views. Creation is essentially creating knowledge, so just going into typing in knowledge and having it show up in there. Inference is running and creating inference agents that can contribute to new knowledge based on knowledge that's already in the graph. And curation is the import of knowledge from external sources. So things like I mentioned DOIs before, or semantic ETL tools. Those are all different ways of pulling knowledge into the knowledge graph. So creation is very straightforward. You can start off with a kind of a blank page, add a new nano publication. This is a form of semantic markdown, which is probably not the same kind of semantic markdown that John has been working on, but this one predates John's attempt at it. I named it first. This is actual.
I got a bigger mouth.
Oh boy, do you. So basically, you just type in text. It could just be regular markdown. Just start typing, and if you know of any things that you can, specific things that are true about the page that you're on, you simply add it on there. So this is basically saying, here's an RDFS label that it's an example homepage. These don't line up quite right. Sorry about that. But basically, once you save that or you add that nano publication, it's the same sort of interface for that. But basically, you end up with a new nano publication that's listed here, and you have some new facts. So you have the facts, a fact panel that shows up on the right, and then basically if there are any descriptions or abstracts or RDFS comments or anything like that, you'll see it up top here as kind of a top-level short description. If you have any shock content, so shock is actually social, what does it stand for?
It's back asterisk.
Semantically interlinked online communities.
Okay, semantically interlinked. So basically it's semantic.
Shock spelled SIOC.
SIOC, as the Irish do. Basically it's a way of describing blog content, essentially.
Yeah, that's exactly right.
Yeah, and so basically if you put in some shock content into your knowledge, it'll just show up as article text. It'll just put some content in there.
So is it up to the user to decide what constitutes like a nano publication? So like if I say, oh, I think the smallest unit of knowledge I care about is X, and then you say, no, you're wrong, you can totally break this up into two things. Is there like a...
Yeah, sure. Well, so generally, it's about those other two things, the provenance and the publication information. So if the provenance, so if you have a set of statements, and the provenance for each of those statements is identical, and they only make sense when they're together, then yeah, they all belong in one assertion. If you have if you want to explain where you got something and it came from two different sources, it probably should be in two different nano publications. So otherwise you'd have to disambiguate that I got this piece from here and I got that piece from there, and it gets more complicated to actually describe in here. If you say that everything in the assertion came from this source or came from this experiment, it's much more straightforward.
Right, so now the data has to be semantically annotated, right? Or can it just be in text form?
You can just type, so for this, you can just write text
Okay.
and have it be in there, yeah.
And internally, how is it represented? Sorry, yeah.
It's represented, so actually it's represented as, basically there's in this case here, what happens is the assertion graph.
Okay.
So each of these has an identifier, because there's an assertion graph, provenance graph, and a publication information graph, and also kind of the nano publication as a whole. Each of them has an identifier, and so when you type in that text there, the graph, it doesn't have any content in it, but what it has is it's given a prov value with the text that you typed in.
Okay.
And actually this format is the MIME type, and so the graph is given, so the graph URI is also given a content type, literal.
So that's kind of analogous to something like Drupal or WordPress, where you specify, I'm giving you this format.
Yeah, exactly. The cool thing is that actually, so it's not just semantic markdown. You can put in HTML directly. You can also upload any form of RDF that is standard. And actually, I have where there'll basically be a structured knowledge editor. It's not quite there yet, so I don't have it included. But that's actually going to be one of the more useful pieces, because you can, the way it's built will let you kind of automatically generate user interfaces, forms for different kinds of knowledge.
The assertion, could I just write like in turtle syntax?
Mm-hmm. Yeah, you just set the data, the format to turtle.
Oh, okay.
It's in the list. You can also upload files, and then actually you can, if you click remote, it will basically let you type in the URL and it will grab it from a remote source.
So even in that case, like you'll have prov value and then whatever the nano publication, and then that would be the graph. Is that how it's represented internally? Like if you were...
Yes, so, but it's also parsed out as RDF.
Oh,
So,
okay.
so essentially, so when you have, there's kind of a workflow that it trickles through. So semantic markdown goes through the Python markdown engine, markdown RDFA extension added, and it gets rendered as HTML. That gets added to the shock content predicate for the assertion. So there's basically two text pieces to that. And then what happens is anything in the shock content, if it's if it's HTML that's in shock content, it'll get run through an RDFA parser, and that gets pulled. You pull all the triples out of that. That gets added to a graph. That graph gets put into the assertion named graph. So if you instead give it turtle,
Right.
it'll just parse it as turtle and put it into the assertion graph.
Okay.
And that process that I described is also true for the provenance graph and publication information graph. So you can just, let's see, you can go, when you create a nano publication, so basically there's each of these here.
But it seems to me, so while the answer is yes to being able to put in turtle or whatever, it seems to me you want to be careful about that, because part of the point of nano publications is like minimum things that you can make assertions about. So that like the smallest bit of information that you would want to usefully refer to and make some assertions about. So you
Right.
wouldn't want to go and throw graphs in as your,
Well, you
as
could.
you could, but
You could, but
but
if
does it
it's-
make sense though if it's if
It
you've got
depends on the
entities-
graph. It depends on the graph you're throwing in. If all you're saying is, so for instance, one kind of nano publication is, let's just snarf down all the information on this DOI
Yeah.
into a graph in Satoru, and that's actually that's how the importer works. What happens is that the publication info is populated with the information that it was quoted from this remote URI and gets pulled in. In fact, I think I showed it but didn't show it. Yeah, so basically you have the revision of when you have a particular person that's contributing it, that gets added. And then if you're actually pulling it from a remote source, it will add a prompt was quoted from thing. So again, this is about, basically it's about attribution and justification. So if you can attribute or justify these things in mass, and it's a big chunk of data, that's fine. That's fine. That's just what you have. If you want to import an ontology and import it all in one go, in one graph, that's where you got it from. You know, that's all the provenance you have, is that someone made this ontology and put it out there.
So you say it's totally in play that I've got I'm building this massive graph in Blaze Graph, and I've got like 10 remote URIs that I'm sucking, and each one is huge, and so I might have 10 nano publications, each referring to one chunk of my big graph, but I've got all this information about what I just did, which is
right. Well, the curation process keeps track of what you did in order to get that in there. So if you're pulling it, if you have some sort of external process that builds those graphs, it would be really nice if you added that to the assertion graph, that this is how I got this. Maybe quoted kind of the ultimate source it came from, or said what process I used to create it. But if you don't have that, all you have is someone published this giant resource that talks about a bunch of different stuff. It's still knowledge of a form. The thing is with the knowledge graph is that it's up to the developer of that knowledge graph to determine what counts as knowledge from kind of a evidence perspective. So if you can just have everything be blank in the provenance and not worry about it. But that's your epistemological criteria for it, is that because I said so.
Well, what's nice about this is actually that use case I just cited, because today I can go and kind of build build a big graph in Blaze Graph, and I don't know anything about all those chunks I just put in there. I could
Right.
construct that. I could do that manually. I could add the RDF that says what this is. But what you're providing is sort of a little wrappers that I could do essentially the same thing, pull in all of those. But now I can know something about the version or something about the.
Yeah, when it was modified,
Yeah.
where it came from, et cetera, et cetera. Let's see. So the next piece, actually, curation. This is actually where it really comes into play, because I folded in a tool called Settler, Semantic ETL, into Satoru, so that you can take settle scripts and add them to the knowledge graph. Basically, so you know how you can just choose file, upload. You just upload a settle script in there, and basically there's a inference agent in there that is the Settler engine. It looks for new settle scripts, and it will reprocess them based on how you configure it every night, and it'll process them when you load it the first time.
So there are people who don't know anything about Settler.
Yes. So
Can I ask a clarifying question? So
yeah.
I get the part about the settler script, but it has to refer to a file with the data, right?
Yeah,
So
and often that file is available either on the web or in some other through some other API.
Okay, got it.
And so if it's file on disk, on the server, that's also fine. You can refer to those things, although you then would need a shared file system for your workers, which is not necessarily the case with. You can have the inference agent system is actually very distributed. You can scale it out very far. But to your point, so Settler is basically a way to generate RDF from lots of different kinds of data sources: JSON, XML, tabular data, and HTML. Basically, it parses those into in-memory structures. It will stream through them line by line, so you can process very, very large pieces of like gigabyte plus XML, gigabyte plus JSON, and it will do that basically chunk by chunk, depending on how you create it. We have a templating language called JSON LDT that basically is a data skeleton for how to interpret each row, whatever the row is, in your data as a chunk of RDF, and then those get aggregated together into a single, basically it's a single RDF graph on disk that's kind of uses Berkeley DB actually behind the scenes, and then it pushes those graphs or graph, depending on how you construct it, to Satoru. Cool thing is that if you just make one large graph, what it'll do is it'll say, oh, hey, there aren't any nano publications here, but there's this one graph. Let's wrap this in a nano publication, give it some publication information that was generated by Settler, and push it up, done. You can also create many, many nano publications inside of this process, because this actually supports named graphs. You can create many different named graphs. You can actually have the named graphs for each piece of the nano publication. You can give them URIs, are always true for each row, so that when you rerun it, it will actually know to retire the old version of that row and upload the new one, and basically keep everything consistent and not have data collisions.
So,
What?
What's the settle script?
The settle script. I'll show you a example settle script. So, wait, did I? Right. So,
it's only a part, right?
yeah, it's in fragments here, but basically you have extract. It's basically a turtle file, so it's just an RDF graph where you have extract events, and you say this table was generated by a extract and used a particular file. You have transforms, where you say that an RDF graph, which is a void data set, was generated by a subtle transform that was also JSLDT and used particular data resources, and then provide these templates. This is JSON-LD, which is a JSON-based RDF expression, or an RDF JSON-based RDF format. The nice thing about it is it's very suitable for templating because JSON-LD is a specialization of JSON. So what I did was I added some extra special pieces to JSON-LD for conditionals and looping and a couple other pieces, which allow us to generate actual RDF. So this is kind of the JSON-LD T that gets created, and then that, given a particular row, would actually graph, which gets translated into, basically this set of triples. So this input table up here actually gets turned into this RDF graph down here. And then you can spit things out to a particular to a file on disk, although that's not really the graph.
But to be precise, not all of that was converted though, because not all of it was
right. This was just,
so you only specified certain columns be picked off.
Right, exactly. Just row.id and row.name. So it doesn't do everything automatically. It does it only does what you specify. So there are ways of doing kind of naive interpretation of RDF into this, actually,
It sounds like you have to customize a lot for the status script before it can be used in a particular graph.
Well, yes, because you can create literally any RDF from any data, and so it's a language where you're specifying the interpretation of that data as RDF. So you have to know what you want to make.
But think of the other options. How else would you do this?
I don't know, I'm just trying to figure
Well,
out.
no, you know the answer because you're a Tetherless World graduate student.
You parse it.
Well, one of the options would be to use CSV to CSV to RDF or LOD,
Yeah,
right? And how do you do that? What do you have to do?
I've actually never used that software.
Oh, was that recorded?
Oh,
That was recorded.
Tim.
All right, so you've got to do that, okay? Which is you get raw, which is a template, and then you customize it for how you want to convert each column to particular.
A template. You still have to know what kind of RDF you're going to make. Disadvantage is that it's harder to see what the RDF is going to be from what you're kind of writing in CSV to RDF, because it's very declarative, and so it's much more. You have to keep the vision of what you want in your head, and then translate that onto paper. What the CSV to RDF should be. With this, the templates are much more. Let's see if I can find it. So the templates are a lot more consistent with the RDF you get back. So
yeah, so I had a question. So one of the challenges, and the reason, part of what I was, so there's certain data tidying type operations that you can do also. And one of the challenges with CSV to RDF or LOD is sort of time series data. There's data structures coming in that you can handle, but they're feats of strength. And actually, there's an example over on that board about rotation. In our universe, dplyr can actually rotate that very nicely.
Mhm.
And I'm wondering that same sort of thing here.
Well,
Can you nicely rotate, or do you?
Yes, here's the so here's the simple and the less simple way to think about it. So in Settler, you're working with pandas data frames. And this is one of the kind of the key bits of magic in there, is that pandas is actually a analytical a data analysis framework that lets you do data rotation, data filtering, trimming, criteria, grouping, summaries, like everything. The other thing is that Settler lets you embed Python functions as intermediate steps in your tool. So you can pass a frame to a function, do whatever you want to do to that frame and that function, and return what you want back, and then process on what you get back rather than processing on the original data frame. So it's actually possibly a little too powerful, but basically it won't limit you in terms of, because those functions that you embed in there, you can have custom entity resolution tools, you can call out to APIs, you can do basically anything you can do in Python, you can do in one of those functions. So it's pretty handy, and yes, it will do that stuff pretty easily.
And you're at wrap it up 53.
Yeah. So I just wanted to show some. I'm going to show some code because I want to show how simple it is. The other piece of curation is importing data. So rather than doing a huge writing a settle script and having it process over things in batch, you can basically say you can map entire namespaces in your knowledge graph to all the nodes that say start with DOI /. You can say everything after that / is part of the DOI. So you can make basically matches. So this basically says, does the entity name match the importer that I'm working with? If so, how do I map it to a remote URL so that I know kind of how that goes? When was that modified? And hey, get me the RDF for that piece. And so these can be literally anything. You can have it go to SQL database. You can have it do, you can do whatever you want inside of here. But basically, the general idea is that you're taking a local resource in your graph and mapping it to an external one, and resolving that in some useful way automatically. And so whenever you have so I have one installed here. So if I go to actually, let me see if I can find my. So the knowledge graph paper has a DOI. So what I'm going to do is basically do that and then that. So I haven't loaded this in here. This is basically a blank graph except for this one thing that I added. And so essentially, what it's doing now is erroring out. What did I do wrong? What did I do with my life?
Did you have to tell it to do something?
No, actually, I'm going to use a different one that I know is probably working. Installation of Satoru. It's also error. Okay.
Well,
anyway.
so why don't you describe what
Yeah,
you're doing there? Is the IP address, that's the base of the knowledge graph that you're constructing, or?
Yeah, so basically when you configure this, you can say, for instance, given this prefix where you have something that starts with DOI, and map it out to dx.doi.org.
All right, resolve it.
Make sure you ask for a turtle, and this is actually what it's going to be. And oh, by the way, here's some update Sparkle to run on it, because actually in this case, DOI doesn't include any type for their DOI.
Yeah.
So anyway, so that's basically a couple of different example.
It can be anything you want. Like it doesn't have to be an existing website for the URL. So if I want to map all the DOIs to like madeup.com/DOI, I could do that.
Yeah, sure.
It returns any IDF, right?
Yeah, you would want it to return RDF for this case, because this is the linked data resolver.
Oh, but then you need to have this, right? So because this is specifically going to dx.doi.org. So you can't do any random, yeah, okay.
It's not just to anywhere, you have to go to somewhere useful for it.
Right.
So anyway, and then to set up specific inferencers, you basically list them out here. And then you can actually schedule some inference tasks to run on a particular basis. Now, the cool thing about the inference tasks is that basically it's progressive. So inference tasks can trigger other inference tasks based on the queries they use. So for instance, this shot content happens because there was another thing that said, hey, there's actually no, which one's this one? So basically the importer was able to pull in shot content from elsewhere. And they said, okay, I know what to do with this. And then basically what it does is it pulls out plain text from that and adds it as a in a new data publication. And this thing has this on it, which you can then use because now you have plain text. You can run an entity resolver or an entity extractor on that, get a list of entities that are possibly in that, and then that can trigger an entity resolver that says, hey, does this actually match up with any of the entities in the knowledge graph, and attach those to it, and so forth and so on. Basically, kind of keep going from there. So that's this cycle of update notifications triggering new inference agents, which result in new things being added to the knowledge graph, and so forth and so on. Finally, interaction, which I'm going to probably give short shrift with this because
That's what you were working on when this.
Yeah, exactly. I think that's no, actually things just kind of peter out. Yeah. But anyway, you have the ability to customize. So this is going back to the first one, which is interaction in the middle. Obviously, that was a lot of effort to gather up knowledge together into a single resource. But the question is, what do you do with it? And it's not really useful unless you have interfaces in front of it. So what I've done, and actually one of the very first things I did with Satoru, before it was even called Satoru, was to create a system for basically referring to different kinds of entities in the knowledge graph. So here we have the default one, which is RDFS resource. We have OWL classes or bibliographic resources. And then there are a set of properties that you might define in a vocabulary file that gets loaded that defines kind of how this works. Those have identifier strings, which when you add a view parameter to the node, it will give you that view. And then actually, let me show you what I mean by that. So here, if I say view equals nano publications, it will return JSON with the content that we put into there. So this is basically a list of the stuff that we used. And so basically, because nano publications For all RDF resources, the view template for nanopublications is nanopublications.json. Templates directory, you can do that. It will use that. There are kind of base ones that are built into Satoru. You have the ability to set up your own template directory and basically add templates as needed. And then because Python, you can add modules to it, you can actually add, as I showed you in the configuration file, basically the configuration file is just Python. So you would, to add new inference agents, you just kind of import them and then construct them as part of the
Can I ask
configuration.
a clarifying question? So the first column, are those all query parameters?
No, these are, sorry, this is like a secondary header here. Sorry.
Okay.
So view equals, and then as we view or nanopublications or related nodes or whatever else you define in there, these three are the different classes. Sorry, yes.
So kind of an existential question, rat hole question.
Yeah.
There's you asked for it sort of in a parametric way. But another way to view that is you could ask for it as a at the HTTP level as a content type, and that's
You could, but the thing is that
you'd
we
be
have
fighting
many different
upstream
views.
doing that.
We have many different views based on just the content type. So you can have a bunch of different JSON LD based views. You obviously have many different HTML views. So you can have one that's just a basic, here's the info about this page.
Yeah.
Here's another one that's, here's a detailed visualization of pieces of this. Actually, with OWL ontology, there's one that is a facet browser. That's one of the possible views. The data fitness ticket is one of those views. So that's
That's good. That's a good answer.
Yeah. And then that's not okay.
Thanks for coming tonight.
And then the very last thing before I let you guys go is that the is kind of the scalability of the system as a whole. So BlazeGraph and Celery are both massively scale out based systems. So BlazeGraph has a high availability system where you can cluster together multiple servers into a consistent, coherent graph. And Satoru can perfectly easily look at one of those, look at a sharded database just as easily as a single one. Celery runs on as a producer consumer queue or worker queue, depending on what level of abstraction you're talking about. But basically, it's all server based. So Redis is a very lightweight message queuing system and database that basically is like an in-memory database that can be replaced with a heavier duty one like RabbitMQ or IBM's MQ, any of those sorts of things. And similarly, you can have multiple workers be looking at that queue at the same time. And then finally, Flask is WSGI based, so you can actually scale that out at the kind of the Apache HTTP layer where you can do the round robin DNS and load balancing, all that stuff in there. So basically, not that I've tested it, but each of these pieces theoretically scalable to very large workloads and knowledge scales. So we can have entire clusters of inference agents running. So we can brute force if you really need OWLDL on your in your knowledge graph, you can just brute. It won't be as fast as everything being in memory, but it will scale out much further because it just won't stop.
Right. Now, are you thinking of scalability because of the LOD crawler? Like I saw.
That actually that does one page at a time.
Okay.
So the LOD crawler, it's a queue within a single task, and it says, "Hey, here's the one thing. Let's go fetch it." All it does is it touches that node in the graph, and then the importer does the rest. The importer says, "Oh, this isn't here. Let's go see if there's an updated version." Pulls it in, shows the info.
So I think we should. But before, so a preview of what's sort of the So this has been a fantastic sort of vision of the architecture, vision of knowledge graph engineering with Satoru. And what's sort of the next chunk that we will hear about?
We should hear
Perhaps even
from,
in a couple weeks.
yes, we should hear from someone who can make a example knowledge graph. Just a couple basic pieces that that do some, you know, some curation and some inference and some inferencing.
All right.
I'm saying not.
So that's a hint of a TWed in a few weeks.
Yeah.
All right. So let's thank Jim. Thank you very much. All
Are you
right.
gonna make the slides available somewhere? Because I